So this video is for integrated 3. This is the chapter 4 classwork / homework number 2 on normal distribution. So on this, it says a set of data with a mean of 45 and a standard deviation of 8.3 is normally distributed. Find each value given its distance from the mean. So what's going to be happening here, I'm just going to make a sketch of this. We are going to be having, let me zoom here, a normal curve with a mean of 45. Let me just write that a little smaller. With a mean of 45 and a standard deviation of 8.3. So that means when I go out one deviation, I'm going to add 8.3, 2 deviations, 3 deviations. So I am going to go 45 plus 8.3, and I'm going to get 53.3. So 53.3. And I'm going to add 8.3 again, and I'm going to get a 61.3. Let me just write this kind of this direction. So this one was a 53.3. Okay, and then if I add 8.3 again, I end up with 69.9, sorry, 69.9. Now going the other direction, when I'm going a -1, a -2, or a -3, I'm going to be taking 45 minus 8.3 and getting a 36.7 minus 8.3 and getting a 28.4 minus 8.3 and getting a 20.1. Okay, so that's what that's going to look like. Let me get rid of this for a sec. Move this out of the way. So in this case, when they're asking us for what is the value when the standard deviation is +1 standard deviation from the mean. So +1 is going to be this 53.3. Okay, so I'm going to write 53.3. And when it's a +3 away, that's going to be this one, which is 69.9. So let me come here and write 69.9. The next ones, they wanted a -1 standard deviation. So that's going to be a 36.7. And let me just highlight the other one, which is a -2, which is going to be a 28.4. So let me jot those down. So this one, when it is -1 standard deviation away, was a 36.7. And when I'm a -2 deviations away, that was a 28.4. Now, on the next one, they want us to sketch a normal curve for each distribution and label the x-axis at 1, 2, and 3 standard deviations. So when I'm doing this, my mean is going to go here in the middle. Okay, I'm just put X bar here, and this is a 95. And then when I go 1 deviation, 2 deviations, 3 deviations, okay, 1, 2, 3 deviations, okay. So when I'm here at a +1, a +2, a +3, my standard deviation is 12. So let me clear this. And so I'm going to go 95 plus 12, which is 107. I'm going to go plus 12, which is 119. I'm going to go plus 12, which is 131. Now I'm going to go the other direction. So 95 minus 12 is 83. And this is going to be a -1, then a -2, and then a -3. So 83 minus 12 is 71. And then minus 12 again is 59. Okay, so now let me move this over here. Again, this one, let me draw this. Okay, so this is going to be my mean, 1, 2, 3, 1, 2, 3. Okay, so for this is my mean, +1, +2, +3, -1, -2, -3. This is 100. And I add 15, this is going to be 115. I add 15 again, this is going to be 130. I add 15 again, that's 145. Going backwards, when I'm taking 100 minus 15, I get an 85. Minus 15, I get a 70. And minus 15, I get a 55. Okay, on the next one, similar idea. So let me draw my mean, 1, 2, 3, 1, 2, 3. So this is going to be my mean, +1, +2, +3, -1, -2, -3. This one has a mean of 60 and a standard deviation of 6. So this is going to be 66, add 6, 72, add 6, 78. Going backwards, I'm going to take off 6. I end up with 54. I take off 6, I get 48. I take off 6, I get 42. And the last one of these here on number 8. Okay. Draw this out. Okay, so this is my mean, -1, -2, -3, 1, +1, +2, +3. This, we have a standard deviation of 23.8 and a mean of 23.8, and then our standard deviation is 5.2. So I'm going to take 23.8 minus 5.2. I get an 18.6 minus 5.2. I get a 13.4 minus 5.2. I get an 8.2. Going the other direction, 23.8. Whoops, sorry, I'm doing that the wrong direction. Sorry, this is going to be my 18.6. I'm subtracting. This is my 13.4. This is my 8.2. Sorry. The other side I need to add. So let me switch those around. Okay, so I'm adding 5.2 and I get a 29. I'm adding 5.2 and I get a 34.2. And one more time, and I end up with a 39.4. Okay. Okay, so last set of these. Okay, let me just draw out my lines real quick. And let me just draw it over here too. So my mean, -1, -2, -3, +1, +2, +3. Mean, -1, -2, -3, +1, +2, positive 3. And my mean is 776 with a standard deviation of 60. Okay, so let me clear this. So 676 minus 60 is 616. Minus 60 is 556. Minus 60 is 496. Now going the other direction, 776 plus 60 is 736. Plus 60 is 796. Plus 60 is 856. Okay. And this one here, we're going to have a 54.2. And so 54.2 minus my standard deviation, which is 12.3, we get a 41.9 minus 12.3, we get a 29.6 minus 12.3, we get a 17.3. So if I take a 54.2 and I add 12.3, I get a 66.5. Add 12.3, we get a 78.8. Add 12.3, we get a 91.1. Okay, so here we're going to sketch the curve. Okay, so mean 1, 2, 3, 1, 2, 3. So my mean, -1, -2, -3, +1, +2, +3. In this case, our mean is 51.1 and our standard deviation is 0.9. So I am going to have 5.1 here. Okay, 5.1, I'm going to be adding 0.9, adding 0.9, adding 0.9. So I'm going to have a 6, a 6.9, and a 7.8. So 5.1 minus 0.9, minus 0.9, minus 0.9. So I have a 4.2, a 3.3, and a 2.4. Okay. So now they want us to find between a 6 and a 6.9. So I am looking at this section right here is what I'm looking for. I want the percent. So what I'm going to do on my calculator, I am going to go to second and vars for distributive. I'm going to come down to number 2, normal CDF. And I'm going to be going from 6 to 6.9. And my mean is a 5.1. And my standard deviation is a 0.9. Okay. So what I was typing in was I was doing a normal CDF of 6, 6.9, mean of 5.1, standard deviation of 0.9. And my answer is 0.1359. So 13.59%. Okay, the next one, we want greater than 6.9. So I want here out. That's what I want. So I am going to be doing the normal CDF. Starting at 6.9 to infinity, but infinity is going to be 10 to the 99. Still a mean of 5.1 and still a standard deviation of 0.9. Okay, so let me enter that in. Whoops. wrong one. Sorry. Second distribution. Okay, number 2. And I want a 6.9 minimum, a 10 to the 99, that's infinity, a 5.1, and a 0.9. And I end up with a 0.0228 if I round. And so that's going to be a 2.28%. Okay, next one, between 4.2 and 6. So between 4.2 and 6, between 4.2 and 6 is going to be from here to here. Now for this one, I actually can tell us that this is going to be about a 68%, right? Because it's one deviation on either side, but let's put it in and get the exact decimal. So normal CDF, minimum 4.2, maximum 6, mean is 5.1, and standard deviation is 0.9. So let me enter that in. Okay. And again, I went to number 2 there. So this is going to be a 4.2, a 6, and 5.1 to 9. And I get a 68.27, 0.6827, which is a 68.27%. Less than 42. Okay, less than 42 is going to be this side. Now, less than 42, I'm going to be doing a normal CDF. Let me move this over. Normal CDF, negative 10 to the 99. It's really negative infinity. 4.2, 5.1, and 0.9. Okay. And so when I put that in, I go down to number 2. Negative 10 to the 99, not minus. You want to make sure you do the negative. 4.2, and everything else can stay. And I end up with a 0.1587. So about a 15.87%. Okay. On number 16, let me write it in a different color. Okay. So this one is going to be a normal CDF. I want less than 5.1, so less than 5.1. Actually, for this, less than 5.1 is going to be this half. Okay, so it would be a negative 10 to the 99, because it's negative infinity, to 5.1, to 5.1 for the mean, and 0.9 for the standard deviation, but that's going to be 50%. So that's going to equal 0.5 or 50%. I don't really need to put that in because that's going to be half the data. The next one is going to be from 4.2 to 5.1. So that's going to be this section right here. So for that, I'm going to do normal. So it should be about a 34-ish. Normal CDF. And let me just put it here, minimum 4.2 to 5.1. My mean is a 5.1 and my standard deviation is 0.9. So when I put that into my calculator, so I'm going to have a 4.2 to 5.1, and everything else is going to stay. And I get a 0.3413, which is about 34.13%. Okay. The next problem. The tests are normally distributed with a mean of 76 and a standard deviation of 10. What percent of students score above a 90? So I am going to have a normal CDF. Okay, I want above a 96. So 96 is going to be my minimum. Infinity, or 10 to the 99, is going to be my upper bound. My mean is 76 and my standard deviation is 10. And I'm going to put that into my calculator. And 96, 10 to the 99, 76, and 10. I end up with a 0.0228, so a 2.28%. What percent of students score below a 66? So this is going to be normal CDF. Negative infinity, which is negative 10 to the 99, 66, 76, 10. And so when I put that in, negative 10 to the 99, 66, I end up with a 0.1587, so 15.87%. What percent of students score between 70 and 80? So that's going to be normal CDF, 70, 80, that's the upper and lower. Mean is 76, standard deviation is 10. Whoops, sorry. Clear. So number 2, I want number 2. So 70, 80, 76, and 10. And I get 0.3812, so 38.12%. The number of nails of a given length is normally distributed with a mean of 5 and a standard deviation of 0.03. What is the probability that a nail is less than 4.94 inches long? So normal CDF. So less than 4.94 means negative infinity. So negative 10 to the 99 is the lower bound. 4.94 is the upper bound. The mean is 5. The standard deviation is 0.03. Okay, put that into my calculator. And when I do negative 10 to the 99, 4.94, 5, and 0.03. And I get 0.0227, so 228. So 2.28%. Normal CDF. 4.97 is lower, 5.03 is upper, 5 and 0.03. And when I put that into my calculator, this is going to be a 4.97, 5.03, and I end up with 0.6827 or 68.27%. What's the probability that a nail is over 5.03? So normal CDF. The lower is going to be 5.03. The upper is going to be infinity, or 10 to the 99, 5 and 0.03. And so when I do that, and I go 5.03, 10 to the 99. Okay, I get 0.1587 or 15.87%. Okay, and on 20, The weights of the food are normally distributed. The mean of the weights is 50 pounds and the standard deviation is 0.2. What percent of pet food weigh less than 49.8? So normal CDF. And let me say this on the top, on the ones above here, these are probabilities. So we could just leave them as these decimals. You don't have to change them to a percent. Probability can be as a decimal. That would be acceptable. Now these ones, they do want it to be percents. So normal CDF, we want it to weigh less than 49.8. So it's going to be 10 to the 99 is the lower, 49.8 is the max or upper. My mean is 50 and my standard deviation is 0.2. So when I put that into my calculator, negative 10 to the 99, 49.8, 50, 0.2, we end up with 0.1587, which is 15.87%. In a group of 250 bags, how many would you expect to weigh more than 50.4? So first I need to find the percent. So normal CDF, more than 50, so 50.4 is my minimum. 10 to the 99, which is infinity, is my maximum or my upper bound. 50 is my mean and 0.2 is my standard deviation. So when I put that in and I put in 50.4, 10 to the 99, I end up with 0.0228. Okay, that's my percent. So I'm going to take 250 and times it with that. Okay, so I'm going to keep that in my calculator and go times 250. And we end up with 5.69 as our answer. So out of 250 bags, about 5.7 bags. In a group of 50 bags, how many would you expect to be within 1.5 standard deviations of the mean? So if we wanted 1.5 standard deviations of the mean, okay, what I'm going to do is I am going to find the percent. Okay, I am going to be just keeping this right now as 0, 1.5, negative, positive 1.5, because that percent is going to be the same as the percent if it was not a standard normal with a mean of 0 and standard deviation of 1. Let's just kind of see what that will do. So I'm going to go to, let me clear all this. I am going to go to my calculator. Okay. My lower bound is going to be a negative 1.5. My upper bound is going to be a positive 1.5. I'm just going to have this be a 0 and a 1. Okay. And that ends up being 0.8664. So I'm going to take that 0.8664 times 50. Okay, so I'm going to times this by 50. And I get 43.32, so about 43 bags. And that's the end of this video.